Hi, I'm Sunnie. I'm a PhD student at Princeton University, and I do research mostly on explainable AI and also human-computer interaction these days. And yeah, I guess I'll just talk about what I've recently worked on so you get a sense of like what I do and like to work on. And this is a quite recent paper. It's called Help Me Help the AI, Understanding How Explainability Can Support Human AI Interaction. And it's an HCI paper that is to be presented at XAI in a couple of weeks. So it'll have a different flavor than maybe like papers that you've read in AI conferences. So I hope it can provide like a complementary perspective. And lastly, this work was done with our collaborators, Elizabeth Ann Watkins, Olga Rosakowski, Ruth Fong, and Andres Monroy Hernandez. So, okay, let's see. So our paper is about, explainable AI and human AI interaction. And I guess, as all of you would know, this field of explainable AI was really born to meet people's need for understanding how AI systems work, right? And there's a need for this in various different settings. Maybe for AI researchers like ourselves, we might want these tools to understand what the model has learned, how it behaves so that we can improve them. It might be useful when AI systems are deployed in high-stakes decision-making settings. For example, when it's used to make, medical decisions, as shown in the example on the upper right, or in these like specialized cases where, AI systems are known to outperform like humans. For example, a couple of years ago, or maybe even more than that now. We know that for a lot of the games, these AI game engines beat the best of human players. And in these cases, we might be really curious, like, oh, like what logic are they using to beat the best of human players? So this might be another source of need for understanding AI. But I also want to talk about some of these more daily and mundane use cases, right? Because AI systems, whether we like it or not, are supporting various areas of our daily lives, from unlocking our phone with face identification to maybe driving in cruise control mode, or just getting recommendations on like what to watch next on YouTube and more, right? Like this was like a screenshot that I took a couple of days ago of what YouTube is recommending me to watch. And whether we realize this consciously or not, like AI systems are really widespread in our daily lives. And what I want to I guess, emphasize here is that everyday AI end users like ourselves might want to understand AI as well, right? So we can better use them, interact with them, and ultimately achieve the outcomes that we want more effectively. So to provide such understandings, there has been a surge of interest in this field called explainable AI. I would say it's one of the most fastest growing fields because I think I see at least like hundreds of new papers each year in various disciplines and domains, ranging from like AI, of course, but also HCI, social and cognitive sciences, philosophy, and so on. And to make this point, I basically grabbed a bunch of like survey papers that I found that were published for various domains, ranging from healthcare, energy systems, autonomous driving, climate science, and so on. However, much of these fields, efforts are focused on developing new algorithms. And I would say there's relatively little attention that's been paid to people who are using or being affected by AI systems or the specific context in which these systems are deployed. Which is why the field has received some, criticism that it's basically inmates running the asylum. And this warning was, given in 2017 by Tim Miller and colleagues, but I would say it's still very much relevant in the current state of the field because a lot of the times AI or XAI researchers and developers tend to develop these tools for ourselves and not really consider the needs of AI end users who might have different needs and use cases for these explanations. So little is understood about what AI end users want and how they want to use explanations and also how they perceive them. And I would say this is because much of prior work has focused on developing new technical methods without humans and also evaluating them through automatic evaluation metrics or short experiments with MTurkers who are often placed in a hypothetical AI use setting. And yeah, and then it is usually it. So to address this gap, what we tried to do in our work was basically conduct a qualitative case study with real end users of an AI application. And since we were one of the first to focus on understanding like real AI end users' needs, we chose in-depth interviews as our study method rather than conducting like a large-scale study. Yeah, that prior work has often taken. So more concretely, here are some research questions that our work really set out to answer. So first, what are end users' XAI needs in real-world AI applications? Second, how do end users intend to use these explanations? And third, how are existing XAI approaches perceived by end users? And to study and answer this question, we look for a research setting that satisfies these two properties. So first, a setting that involves real-world AI use by end users with a diverse domain and AI knowledge base. And this was because we believe these are important factors that determine how end users interact with AI systems. Second, we also look for a setting in a domain with significant AI and XAI research. And this is because we wanted to mock up like XAI explanations and augment the end user's experience to study our third research question. And for these mock-up explanations to be realistic and also closely reflecting the state of the art, we were really looking for a domain with significant research in both of these areas. So the research setting or the study application that we ended up finding was the Merlin app called Merlin app for bird identification. It is a free mobile phone app that's very popular. It has over millions of downloads and is used by a lot of people with various levels of domain and AI background. And yeah, and it's, as the name suggests, it's a bird identification app. So I'll briefly show you the interfaces, but what it does is if you give the app like a picture of a bird or like an audio recording of a bird, it'll run like an AI system, AI model, and basically tell you, what type of the bird it is. So yeah, here are some snapshots that I took from the photo ID feature. So what you can do is upload or take a photo, provide some optional like additional information like location and date, and the app will tell you what bird it is using computer vision AI technology in the background. And similar story for the sound ID feature. Here you can input audio recordings, and then the app will tell you, all the different types of bird it thinks it heard. And it's really fun. I think you should try it out if you're interested in birds. I actually learned a lot about birds while conducting this study myself. And one thing I do want to point out is, as with most AI applications, Merlin does not provide explanations for its outputs. Like, as you can see from the screenshot, it'll tell you what bird it think it heard, but it's not going to explain why it think it's these particular birds or how it arrived at its particular output. But the Merlin app was really nice in that it did provide us with some grounded context, right? And with real end users whose experience we can augment with mock-up explanations that have been, that reflect like the state of the XAI field. So I don't know if you are familiar with this or not, but bird identification also happens to be a domain with significant AI and XAI research. Thanks to the CUP dataset, which is like a large-scale, very popular data set with images of birds of 200 different types of species. XAI methods for computer vision has been developed and evaluated on bird image classification. Here are some example works and screenshots of the various explanations that have been proposed in them. And this is really great because it means that, well, first of all, whatever mock-up explanations that we show to participants are quite realistic and reflective of the state of the art, but also the feedback that we collect from the mock-up explanations can provide concrete and immediate insights to the XAI researchers working in this space. So let me briefly go over the study methods that we employed in 3 parts. So first, we recruited participants who are end users of Merlin's photo ID and sound ID features that I've shown previously. And we also really tried to maximize the diversity of domain and AI background of our study participants. And to quickly give you what these different categories mean, low domain participants were those who don't know anything about birds or just recently started birding. Medium domain participants were those who have been birding for a few years or can identify most of the local birds they see. And high domain participants were those who've been birding for years or do bird-related work, such as researchers or ornithologists. And then for the AI background column, low AI background participants were those who don't know anything about AI or have heard about a few AI concepts or applications. Medium AI background participants were those who knew the basics and maybe can hold a short conversation about it. Or there were also participants who have taken like a course or had some experience working with an AI system. And then finally, high AI background participants were those who use, study, or work with AI in their day-to-day lives. So once we recruited participants with these varying levels of background, we conducted interviews on Zoom. The interviews lasted about an hour on average, and they included open-ended questions, but also a quick survey, as well as an interactive feedback session on the mock-up explanations that we created. And I'll talk about these in more details in the coming slides. So after we conducted the interviews and collected the data, we did data analysis. So how this usually works in a lot of qualitative studies is we first transcribe the interview scripts and then analyze them using a process called descriptive coding. So what we did concretely was we first read through 5 transcripts to develop something called the code book. And the codes were, I guess, like units or patterns that we observed in the data. And during multiple group meetings, our research team, iterated and refined the code book and then identified some common themes that seem to be present in the participants' responses. And using this code book, we basically, coded all of the 20 transcripts, which became the basis of our, study findings and synthesis that I'll present in the coming slides. So our interview was structured in 3 parts. So first, we asked participants a series of questions aimed at learning the context of their app use. These included questions about their background, their goals and stakes in app use, and their general experience with and perception of the app and AI in general. And after we learned the context, we next inquired about participants' explainability needs through both open-ended questions and a survey that we developed from an existing work called the XAI question bank. And what the survey looked like was basically there were 10 different categories of questions that people might have about an AI system. And we showed these to participants and asked them to select questions that they know the answer to and are curious to know more. But what we also did after the survey was, basically follow up and ask, how much effort they would spend to get the answers to these questions to really get an accurate assessment of how much explainability needs they have. And finally, we assessed participants' perceptions of existing approaches, as well as how they intend to use explanations. As follows. So we used screen sharing during the Zoom interviews and showed them 3 identification examples from the Merlin photo ID feature. So I don't know if you can see this clearly, but the first example was a correct identification. The second example was a misidentification, but one that people, like even experienced birders, would make. And then the third was a misidentification, but one that people wouldn't make. So, misclassifying an airplane photo as a bird. And we used these 3 running examples to introduce different XAI approaches. So we had 4 in total. We introduced 1 at a time and in random order. And these were heat map-based explanations, example-based explanations, concept-based explanations, and prototype-based explanations. And these cover the range of popular explanation forms that exist in the explainable AI for computer vision field. And yeah, one thing I do want to highlight is while the identification examples were real, like I got them by feeding in the photos to the app and then taking a screenshot. These mock-up explanations were something that we designed, and I will talk about each of them in more detail when I summarize participants' feedback on them. Anyways, After I introduced each of the approaches, I asked participants how they wanted to use it and also what they liked or disliked about each explanation. And at the end of showing all four, I also asked them what their favorite and least favorite were. Okay, so we can finally move on to talking about the results. I want to begin unpacking participants' explainable AI needs. And I know this slide is daunting, but I'll give you a quick summary of how to interpret this table and also how I am, and the takeaways that we've drawn from this table. So here is a table that shows out of 19 participants who filled out the survey, how many of them selected, know the answer to, curious to know more, or neither. And I guess what you can tell by quickly skimming through the table is that a lot of participants that they, knew the answer, that they know the answer to, or were curious to know more. There are very little or very few number of people who were not curious, which seems to suggest that, participants really wanted to know about all sorts of AI system details, including information about the training data, the AI's performance, inner workings, and also more like specific questions such as like how the AI produces outputs and specific inputs and what would happen if we make certain perturbations. And one more thing I want to note here is that some of these are questions that can be answered by just providing more information, like in the form of like system fact sheets. Whereas some of the other questions, like the ones in the categories like why not, what if, how to be that, how to still be this, are questions that require like the XAI methods or algorithms that we're familiar with. Interestingly, though, the picture actually changed when we followed up after the survey, like how much effort the participants were actually willing to invest to get the answer to these questions. And the responses really vary based on participants' AI background and their level of interest in the domain of birding. So high AI background participants, such as ML researchers and developers, had high needs. They were very curious about Merlin's AI, in particular about like technical system details, like, what was their training data? Like what model architecture did they use? Like how was the computer vision model trained and so on. And also these participants were willing to go to the extent of like emailing the app developers or playing with the relevant data and model themselves. Low AI background participants, on the other hand, didn't have as high explainable AI needs. They said they were curious, but also said they wouldn't exactly go out of their way to learn more about the AI system details. Some participants actually said they would prefer to keep the AI as a black box, saying they don't want to ruin the mystique. But there were some exceptions among the low AI background participants, which were those with a notably high interest in birds. They were very curious about the AI, in particular, how it tackles like challenging bird identification problems, such as distinguishing mockingbirds or little brown birds that even experienced human birders have difficulty in distinguishing. So while participants' needs for system details varied based on their AI background and domain interest, all participants, everyone unanimously expressed the need for information that is practically useful. And these included information such as the AI's capabilities and limitations, display of confidence, or just getting more detailed outputs, such as like maybe getting highlights in the sound spectrogram where the bird appears to be singing and so on. And participants said they wanted this information to improve their collaboration with the AI, and in particular, in deciding when to use the AI and accept its outputs. Okay. So next, when I showed the mock-up explanations to participants, they were excited to use them for various purposes. To start with ones that are familiar to us, a common use case that came up was to understand how the AI produced a specific output, which is the goal of local XAI methods that are developed, which is the goal of local XAI methods typically. Another use cases that we know that popped up in our conversations were to calibrate their trust in the AI. Interestingly, though, we also found quite a few new use cases that are less discussed in the XAI literature. For example, participants wanted to learn from the AI via explanations to perform the task better on their own in the near future. Participants also wanted actionable feedback on their own behavior from explanations that would help the AI perform better. So, feedback maybe on like how to take better pictures and recordings or what additional input to supply so that the AI can, do more accurate bird identification. And finally, participants with high AI backgrounds saw explanations as a medium or an opportunity to give feedback to developers so that they can use the feedback to improve the AI in the long term. And I particularly want to highlight these last two use cases because they suggest that the participants viewed the AI as a collaborator. And to improve their collaboration, they wanted explanations to help them help the AI, hence the title of our paper. And we found this a very intriguing repurposing of explanations that are typically, developed to help people understand or calibrate their trust. And I think these also highlight the broad range of user goals that should be considered in XAI development, because I guess developers of these methods might consider only a few use cases, but then when they're actually deployed and are used by people, they might want to use them for various other, maybe unexpected purposes. So it would be good to anticipate them in advance and also try to support those needs as much as possible in the development process. Okay, so I guess the remaining question here is then whether current explainable AI approaches are satisfying end users' needs and use goals. So now I'm going to talk through each of the four types of explanation approaches that we showed to participants and also summarize the feedback that we've received. I think this might be the most relevant bit for the XAI community, especially those who are trying to develop new methods, because it'll provide some insights into how end users are viewing these explanations. So I'll start with heat map-based explanations that are perhaps the most popular or at least well-studied in the field. So these are explanation approaches that highlight regions in an input image that are important for the AI model's output. And these cover, feature attribution methods like BradCam and other, tens and maybe even hundreds of other feature attribution heat map methods. And when I showed these to participants, I got a mixed feedback. So some participants thought these were quite intuitive and pleasing to look at. Some said they seem to be helpful for spotting the AI's mistakes, especially when it seems to be looking at like regions that are not part of the bird or regions maybe that are incoherent. However, participants also said, some of them said these were unintuitive and confusing. I got this feedback a lot. Participants said the particular heat maps that I showed were uninformative because they're too coarse. A lot of participants told me, hey, it's basically highlighting the bird. Like, what am I supposed to take away from that? Like, it needs to be more like specific and localized to be really helpful for, understanding like what the model was looking at to arrive at its bird identification outcome. Further, participants said, heat maps don't explain why these parts were important. They just tell you, which parts were important. And also that it doesn't give them any actionable feedback that would help them, help the AI achieve bird identification better, or actionable feedback on, like what they're supposed to be looking at or looking for in the future. Next, I showed these example-based explanations. You can think of them as explanation approaches that show examples in the training data that the model has already seen that are most important for the AI model's outputs. So these include, existing methods such as influence functions or representer points that identify important positive and negative training examples for a particular output. So when I showed these to participants, a lot of them liked it for its intuitiveness. People said they were pleasing to look at and also helpful for verifying the AI's outputs, because what participants can do when they see these additional explanations is basically do a cross-check, right? Like, oh, do these examples that were returned to me actually look similar to the input image that I gave to the app. So participants like that they can, do this cross-checking and said, this type of approach allows end users moderation, which they appreciated. But also some participants said they were quite uninformative and maybe too impression-based. Some also said they don't add much to the current examples in the app and that they don't give actionable feedback. So yeah, again, these show some like mixed range of feedback and mixed range of perceptions that can be that should be taken into account when developing these methods. And then moving on to concept-based explanations that explain the AI model's prediction with, I guess, text-based semantic concepts. These are meant to include approaches like interpretable basis decomposition, concept bottleneck models, elude, and other types of methods that really try to explain how the model recognizes a particular class as a linear combination of semantic concepts. So to briefly explain how to interpret these explanations, so basically it has a list of concepts and then has some coefficients in front of it that tell you whether or not the presence of those concepts are a positive evidence or a negative evidence towards recognizing a particular class. So here, if we look at the evening grosbeak example, it's saying that the presence of yellow beak, black feathers, yellow body, and round body are, positive evidence for recognizing evening grosbeak, whereas the presence of long beak and white body are negative evidence. And the ones that are crossed out are the concepts that the model didn't recognize in the particular input image. So it serves as both like a global explanation of how a model recognizes a particular class, as well as a local explanation, because it lets you calculate these specific scores for a given input based on the presence of concepts. So when I showed this to participants, again, mixed feedback, participants really liked the part-based form because they really resembled how people reason and explain bird identification. Participants also said they were helpful for verifying the AI's outputs because what they can do now is, because they have access to so much information, they can now go through each of these concepts and see whether or not they agree with the AI's recognition, right? Like, here, like longbeak is crossed out, but what if longbeak actually exists in the input photo? Like that sort of discrepancy would be a chance for participants to really inspect and determine whether or not they want to trust the particular AI output. Another praise that was given for this approach was that it was helpful for just learning how to do bird identification, because now they can pay attention to these semantic concepts and use them for their own birding in the future. And finally, participants also liked the numbers because they were quite specific and informative, as opposed to, I guess, more impression-based approaches like heat maps and examples. It also received some criticisms though. So one thing that I heard frequently was that the current concepts that were included in the explanations are too generic. And this was a very interesting moment for me because I mocked up these explanations by using the part labels in the cup data set. But then I guess talking to participants, most of them who had like more birding expertise than I do, really helped me realize, like, I guess the discrepancy between, these generic concepts and the domain specific language that they use and are used to. So I think this really highlights the need of involving end users and domain experts when designing these explanations for specific application. Also, some participants complained that the coefficients were difficult to interpret, or just that these numbers, like having a lot of these numbers, were overwhelming and wasn't necessarily a type of explanation that they were looking for. The final type of explanation approach that I showed to participants and received feedback were prototype-based explanations. You can think of them as quite analogous to concept-based explanations, except here the parts are now like visual parts. So rather than semantic concepts, it really decomposes a prediction into like visual parts that the model has learned during the training process. So, like the model looks at these types of prototypical regions when trying to classify evening grosbeak. And I guess to explain a bit more, what happens at test time then is once I give the AI like an input photo, it's going to find regions in the input photo that closely resembles like the prototypes that it has seen during training. And based on their similarity, like make a decision on whether or not this bird is of a particular class. So I'm kind of showing you how like an input region has been matched to a prototype, as well as a notion of similarity between the two regions. And these represent methods in the like methods such as proto-PNet, proto-tree, deformable proto-PNet. I know there are multiple more recent works. It is actually one of the most popular approaches, I would say, in the computer vision, mostly because they are, one of the few like interpretable by design models that are working they're working quite well in the computer vision domain. So when I showed this participant, these two participants, they were actually a lot of people's favorites. People like the part-based form for similar reasons. They resemble how people go about bird identification or explaining their identification to other birders. Participants said they found these quite intuitive due to their visual nature, and also said they were helpful for verifying the AI's outputs, because now what I can do as a user is actually, check whether the regions that are being matched are like similar looking regions, and whether or not the similarity scores like make sense to me. Participants also said these were helpful for learning how to do bird identification, because they give you insights into what parts to focus on when identifying a specific bird. I did receive some minor complaints. Most of them are actually regarding presentation or visualization of the explanation. So people said they were quite cluttered and might be difficult to see on small screens. Given that Merlin is like a mobile phone app, maybe showing parts in this way might not be the best presentation method, because you would really have to zoom in to see what's happening. And finally, participants said some prototypes were ambiguous and uninteresting. So if you look at some of them, you'll actually see that there are, prototypes that are, highlighting the bird's feet. And participants caught this and were like birders never look at birds' feet because they're not informative. So this kind of suggests that, some curation of prototypes might be needed with domain experts if they were to be actually deployed in practice. And also, it also highlights some errors that can be happening in these methods. Like, for example, when prototypes are learning like non-bird parts, such as the branches or part of the background and so on. So yeah, our participants really caught these different weaknesses of weaknesses of this approach. And so I do want to highlight this part before moving on to the conclusion, which is that the perceptions of explainable AI approaches really depended on people's AI background. And here are two like salient examples of when perceptions diverged. So for heat map-based explanations, those with high AI background found them quite intuitive and familiar and helpful for representing information. Some people said, oh, like I use heat maps all the time in my research, so it's very intuitive for me to interpret what's happening, like when I see this heat map explanation. Some of the low AI participants, however, said they were, heat maps were not intuitive. Some said, heat maps reminds them of the weather and wouldn't want to see these as like an explanation in a bird identification app. So it reveals some individual differences in perception and preferences. And similar story for concept-based explanations as well. High AI background participants actually wanted more concepts, more numbers, and wanted to just get the full story behind like the AI's identification. Whereas low AI background participants found it quite overwhelming. This is a quote from one of the participants who said, stuff like this would go right over my head and make no sense. So it would be great to keep in mind, like what your end user is and what their backgrounds are, and whether these explanations would really satisfy their needs or would be preferred by a lot of the target users of explanations. So, okay, so here is a summary slide. And what I really want to like highlight through this work is that there still exists a creator-consumer gap in explainable AI research and development. So to highlight our key takeaways from each of the research questions. So first, regarding explainable AI needs, oftentimes creators of explainable AI systems develop methods to satisfy the need for system details, or things like understanding the AI system's inner workings or outputs. But when we talk to actual end users, we found that the system details were really only wanted by participants with high AI backgrounds. Those without much AI expertise weren't really interested in the system details. And also, participants overall wanted more practically useful information that would help them better collaborate with the AI, more so than the system details that would give them a better understanding of the AI's technical parts. Second, regarding XAI uses, the common motivations or use cases for explainable AI methods are, understanding and calibrating trust. But when we talk to actual end users, we found a much broader range of XAI uses and, goals. Things like, learning from the AI, since this AI system is an expert system, changing their behavior to help the AI perform better, because at the end of the day, getting a good identification result is the goal that people want to achieve by using this AI. And finally, giving feedback to developers through explanations. And then finally, regarding XAI perceptions, the four approaches that I've shown you today are quite popular and representative of the forms of explanations being used and developed in the computer vision field. And they were quite, they're popular because they're, quite satisfactory to people with high AI background. However, as our study found, those with low AI background actually found some of the approaches confusing, not intuitive, or overwhelming. So it highlights, the importance of talking to end users of varying background to really check whether or not participants would be able to digest and make use of these explanations. So I guess in conclusion, I also want to share some of the concerns that were expressed towards explanations. So some participants who are familiar with the explainable AI field raised concern regarding faithfulness. They asked, oh, if I'm seeing a concept-based explanation, is it really faithful if the underlying AI model is just a deep, neural network and not really doing things in a two-step process where the model first recognizes concepts and then uses them to make the final classification. So I think it is really important to keep the faithfulness part in our minds when we're developing these technologies. And then secondly, participants said some of the approaches are difficult to digest, and that explanations could engender overtrust in AI, which is, a commonly known phenomenon that has been verified by a lot of different works. So I think these are some concerns that we need to keep in mind when we're developing and thinking of deploying these into practice. And as the last bit, I have some recommendations for future research. So I really want to highlight the need for designing explanations with end users. I think I had a lot of eye-opening moments when I were interviewing end users and listening to their feedback. So things like, participants pointing out the discrepancy between the concept labels in the cup data set that I was using to mock up explanations and the domain-specific language that they're using with their birders. Participants said, hey, we birders use field markers, there are these specific terms that we use. So the explanations would be much more helpful if they incorporate such, domain-specific language. And then the second point is explanations hopefully would answer why questions, not just what questions. This came up frequently throughout our interviews. Participants, especially regarding heat map explanations, were telling me, oh, it shows, what features were important, but doesn't really tell you why these features are important. So I know the causal interpretability or causal explainable AI is a field that's growing, but I would really like to see more work in that space. And then third, I think explanations should use multiple forms and modalities if possible. So when I asked participants what their favorite were, a lot of them wanted a combination of 2 or more explanation approaches, they wanted the prototype explanation, but also wanted concept labels to be there. or wanted prototype explanations, but also like have like heat maps on it so that there's like a gradient of what's more important and less important, even within a particular prototype. And then finally, participants were also telling me and also asking me whether like the AI that's like powering Merlin was multimodal, because when they go about bird identification, they try to combine information from as many sources as possible, right? Like they try to get a visual identification, like visual, yeah, they try to get a visual of the bird, also try to hear it to see if, they're like singing, similar sounds, and also make use of their prior information, such as like, oh, like whether or not this bird is common for a given area in a given season. So if possible, like if AI systems can incorporate like information from multiple modalities and also produce explanations that incorporate multiple modalities, I think it would much better serve the needs of end users. And then my final point is, evaluating explanations rigorously. Just going back to the point where explanations are known to engender overtrust in AI, I think it's very important to, check throughout the pipeline whether or not these, explanations are really serving end users' needs and, helping them develop an appropriate amount of trust and so on. And as a shameless self-promotion, I do want to highlight some of the work that that I and my collaborators have been doing in this space regarding evaluation. And so yeah, so if you're interested, you can check them out. The first is like a development of an explainable AI methods evaluation. And then the second is really focuses on concept-based explanations and tries to look at the different like assumptions that are made in common work and when these explanations can break, when those assumptions are also broken. And finally, if you like this work, we actually also have a follow-up paper that really dives into whether or not like participants trusted the app and what were the different factors like influencing their trust in the system. So yeah, if you're interested in this, I can also tell you more about it or share a preprint of it. And I think that's it. Here's the last slide with all the different references and sources of images, and I'd be happy to take any questions.